In this tutorial, I'm going to show you 22 steps on how to get started with UDK and begin constructing game environments. Now, if you've been following my tutorials, you may wonder, why am I doing another beginner getting started UDK video? One of the very first videos on UDK I released was UDK Basics Getting Started in 11 Steps. This video was released in 2010. The tutorial was split into 3 parts, and that was back in the day when the time limit for YouTube videos was 10 minutes. So I had to split it into multiple parts. Also, since then, UDK has received a lot of updates, and I felt that an update for this video was overdue. So in this video, I'm going to show you how to get started with using UDK for environment construction. If you are a complete beginner, by the end of the video, I want you to be very comfortable at navigating and knowing what to do in order to get an environment going and what it takes to create and construct a simple basic environment. Think of this video as a crash course that will get you started in 30 minutes with using UDK. Also, in addition to this video, I created a free ebook called The Essential Guide to Getting Started with UDK. This ebook includes over 150 tips, techniques, methods, and advice on getting started and using UDK. And you can grab it completely free at www.worldofleveldesign.com/guides and just click over to the free guides tab and sign up to my newsletter and blog updates to get the free ebook. Alright, so let's get started with the tutorial. First, you need to download and install UDK. If you go to udk.com or unrealengine.com/products/UDK, it will take you to the download site. Here you can use the drop-down menu and download some of the latest versions of UDK. Once you downloaded it, you want to double-click on the installer to install. Choose UT Sample Game, which will install UDK with example files and game code to start with. Next, choose the install location. Keep this at default and click install. You will have an option to install Perforce, which is a revision control system. This is optional, and unless you are working on a project that has multiple people, I choose not to install this, so go ahead, click next. Once the installation is complete, go ahead and choose Launch UDK. Go ahead, close all the menus, and the first thing you will see is a default template that is launched automatically when you open UDK Level Editor. To change this, you can go to File, New Level. You can choose any of the 4 available templates, or you can choose a blank map. The default map templates contain all the necessary elements that you need to start an environment. It has a skybox, it has a fog actor, it has a light, it has a light mass importance volume, a ground plane, a cube, and a player start. What you see now is a single perspective viewport. You can restore back to 4 viewports by coming up in the viewport toolbar, top right corner, and restoring to 4 viewports. You have a side, front, top, and perspective viewport. By left clicking in each one, you highlight and make that viewport active, and then you can maximize that viewport by pressing Alt X, which is a shortcut to maximize and restore that viewport. Or you can use maximize viewport icon on each of the viewport toolbar. If you don't like this 2x2 configuration, go to View, Viewport Configuration, and change to any of the available ones you have here. Choose something more that you are used to. So let's go ahead and highlight perspective viewport and maximize by hitting Alt X. Next, most important thing to know is how to navigate inside viewports. In perspective viewport first, if we use WASD keys, we can move the camera front, back, and side to side. The W and the S key will move the camera forward and back. A and the D key will move it left and move it right. With the mouse, you can look around by holding down the right mouse button and moving the mouse. If you hold down the left mouse button and move the mouse forward and move the mouse back, this will move the camera forward and back. And if you hold the right and the left mouse button together, move the mouse forward and back, this will move the camera up and down. So with the combination of the WASD keys and the right mouse button, you can look around and fly around. very quickly using this navigation pattern. You can also use the mouse wheel, moving it forward and moving it back, to slowly move the camera in and move the camera out. Let's go ahead and switch to one of the orthographic viewports. If we use the left and the right mouse button, hold them down and move the mouse forward and back, this will zoom in and zoom out. If we hold the left or the right mouse button and move the mouse around, this will pan that viewport. And we can also use the mouse wheel, moving it forward and moving it back, to zoom in and zoom out. To select any object inside your scene, left click to select and escape to deselect. When you select an object, a gizmo will show up. This is XYZ gizmo, which you can use to move that object. So by selecting each of these axes, left clicking and dragging, you can move that object. And if you click right in the middle, you can move it along X, Y, and Z axes at the same time. If you press the space bar, this will cycle between move, rotate, and scale tools. And with these you can rotate your object, scale, and switch to move. So spacebar will cycle through all three. And if you go up to the toolbar, you have selection mode, which will only select objects and will not allow you to move them. Then you have translation mode, move tool, rotate, scale, and non-uniform scale, which will allow you to scale objects along a single axis. To delete any object inside your scene, just go ahead, left click to select it and press delete. Let's hit Ctrl Z to undo. And to duplicate any object inside your scene, select that object, hold down Alt, and left click and drag to duplicate it. Alt, left click and drag. Let's open up one of the example files that comes with UDK. Let's go to File, Open, navigate to the installation folder of the version of UDK you're using, UDK Game, and then inside Content folder, Maps, UT3, you have two map files, Deathmatch Deck and Capture the Flag Necropolis. Double click to open up that map file. You can use the example files to learn how the maps are constructed inside UDK. Essentially, when you are creating your own game environments, you'll be using BSP brushes and static meshes to construct your level. Static meshes are 3D objects which are created outside in a 3D application. They're modeled, textured, and then imported into UDK. So all these objects that you see here, all of these objects are static meshes. And if I use Alt W, this will cycle the visibility, all of the available static meshes in the scene. This pink wireframes that you see are collision volumes. So let's go ahead and turn that off so we can see the scene a little bit better and more clear. So I'm going to use the Viewport drop-down menu, Show Volumes, and uncheck Blocking Volumes. So when we use Alt W and turn off all static meshes, what is left are BSP brushes. These are simple geometric shapes that are created and textured inside UDK. And the two menus to create BSP brushes are right here on the left hand side. You have Brushes menu and CSG, which will add and subtract BSP brushes into your scene. But you will notice that the majority of the map is made up out of static meshes, 3D models. So majority of your environment will be made up out of constructing using static meshes to create what you see. But you will also use BSP brushes for the beginning process of blocking in your entire environment, and then using some of the brushes for large flat areas such as floors, some walls, ceiling, and for areas to fill in the gaps between static meshes. But the majority of your time will be spent using static meshes to construct your entire map. There are two ways to access static meshes. First is to create your own inside a 3D modeling application such as 3ds Max, Maya, Blender, Modo, or any other 3D application, and then import them into UDK. Or to start with, you can use the default static meshes that come with UDK. To see what's available, we need to use the content browser, which is your content management system inside UDK. To access this, up in the toolbar, click on the Open Content Browser icon, or press Ctrl-Shift-F. In here, you can filter through all the available assets that come with UDK. Under Object Type, right here, You can filter by animation, material instances, materials, particle effects, sound, static meshes, and textures. So if we left click and filter by static meshes and click on all assets, this will give us all the available 3D models that we can use to construct our environments. And we can use the scroll down and see what is available. We can also filter by textures, see what kind of textures are available, as well as materials. If you need to search for a specific static mesh, such as, let's say we want to search for a wall, just type in wall in the top search bar and then scroll through all the wall names that are available with UDK. You will be using Content Browser a lot to find what you need and to insert any of the objects into your scene. So let's go ahead, check back to all, and let's clear our search menu and close Content Browser. The last thing I want to show you in this example map is the viewport viewing options. Right at the top toolbar within the viewport, you have 11 view and viewport options. Brush wireframe, wireframe, unlit, lit, detail lighting, lighting only, and so on, all the way up until lighting only with textile density. Each viewing option gives you a specific function during the construction process of your environment. Options such as light complexity, texture density, and so on won't be used until you get more advanced into using UDK. But the first 4 or 5 options, the wireframe, unlit, lit, and lighting options, are the most common that you'll begin to use when you're first starting out with UDK. You can also use the shortcut keys Alt-1 all the way through Alt-0 to quickly switch between viewport viewing options. Let's go ahead and start a new map. Let's go to File, New Level, and New Blank Map. When you open a blank new map, all you will see is a red template brush. If you don't see this, hit the B key. This will cycle the builder brush on and off. This builder brush is a template from which you can add and subtract BSP brushes from. This is invisible in-game. To see this as a BSP brush, we need to add by using the CSG function, add, or Ctrl-A shortcut. Once we add that brush from the template, this becomes a BSP brush. Let's go ahead and undo. Let's bring back our builder brush. We can change the builder brush to any other shape by using the brushes menu. So by left clicking, we can use cube, cone, curved staircase, cylinder, and all of these available brush shapes. And once we see that shape, that template, we can then Ctrl-A to add that into the world. Then we can move our red builder brush, change its shape again, and then press Ctrl-A to add that. We can also subtract by using the red builder brush, position, so it intersects already created brush, and by using the CSG function subtract, Ctrl-S, from already created brushes. But note that the subtract only works when you already have additive brushes added in. So let's go ahead and hide that builder brush. If we go to wireframe, you can see we have additive brush, and the yellow wireframe is the subtractive brush. Let's go back to lit mode. You can see that we don't see any of our brushes. That is because we don't have any lights placed. So at this stage we need to use unlit mode, Alt-3. Let's hit the B key to bring back our builder brush. To change the shape of this builder brush, we can right click on any of the brushes menu icons, and through this option menu we can change the size of the red builder brush. We can also do the same thing for any of the staircases or any other icons in the brushes menu. And then once we are happy with the shape, press Ctrl-A to add. So adding and subtracting brushes is very simple. Let's add a BSP ground plane. For this we need to delete all of our added and subtracted brushes. To select brushes inside the perspective viewport, hold down Ctrl, Shift, and left click on the BSP brush to select it. You can also switch over to wireframe and select the brushes this way. This will allow you to also select the subtractive brushes. Then once you select it, hit delete. Let's switch back to unlit mode, and you can see that we still have our BSP surface even though we deleted the brush. In order to see BSP changes, you need to build your geometry. At the very top in the toolbar you have build geometry for visible levels. Go ahead, left click, close, and now our BSP geometry has been updated. Let's hide our builder brush and let's select our stairs. Control Shift left click, hit delete and build our geometry. Now there's an easier way to select BSP brushes and see updated changes of BSP brushes without having to rebuild geometry every time you delete or modify a BSP brush. So let's go ahead to preferences, and first you want to enable click on BSP selects brush. Now you don't have to press Control Shift left click, you can just left click to select the brush. Also on the preferences we want to enable auto updating BSP visualization. This will allow you to modify the BSP brush and it will automatically update without having to rebuild. And now we can select it and delete it. Also let's go ahead to wireframe and delete our subtractive brush. Let's go back to unlit mode. Let's bring back our builder brush, B key. We need to bring back our cube, left click. Let's right click, let's set a few properties. Let's set the height for Z at 64 and let's make it 1024 by 1024. Let's select it and let's position it somewhere right in the middle of the world. Now let's press Ctrl A to add. Hit the B key to hide our builder brush. And this next step is probably the most important workflow step with BSP brushes. You can modify already added BSP brushes by using the geometry mode. So let's enable this. On the left hand side menu, left click geometry mode or press Shift 2. Let's make sure that we deselect our red builder brush by clicking off of it. And with this added BSP brush, we can left click. Now we can highlight our vertices. We can select faces and edges, which is a little difficult. You have to get really close to select the edge. And if you can't select it, you can just go to brush wireframe mode. The edge is a little harder to select. You just have to be at the right angle. Let's jump back to unlit mode. And with the geometry tools enabled, we can select different components and then modify the brush. So let's go ahead and select these 4 vertices on the side and make our cube larger. Once you select the vertices, the edges or the faces, make sure that your reference coordinate system is set to world. This is very important. So once you select it all, you can just extend it and auto update will modify the brush. Left click to select the face and let's extend to make it larger. The way to select multiple objects is I left click to select the vertice, hold on Control and left click to add to a selection. And I'm holding Control while left clicking to add. And to remove, just hold down Control and left click again to remove from the selection. So using this geometry mode allows you to really quickly add and then modify BSP brushes that you already placed within the world. Let's add a static mesh in the middle of our ground plane. Since we need a 3D model, a static mesh, we need to go to Content Browser. Let's filter by static meshes. And in the search box, let's type in cube. Let's select texture prop cube, and a couple of ways of adding a static mesh into the world. So we can hover over here, left click from the content browser, and left click and drag right into the world. Let's select and delete. Another way is to select the object inside the content browser, close the content browser, right click and choose add static mesh, name of the mesh. And now we can go ahead and move it up to place it right on top of our ground plane. We can also switch to orthographic viewport and position it a lot better, right in the middle. So with this, you can add any other static mesh using the same technique. Next, very important element is to add a human reference scale into your map. Right now, we don't know how large this environment is. It's very difficult to tell how large this cube, this ground plane, or this wall is compared to a player. To do this, let's go back to Content Browser. Let's make it a little larger. And we want to filter by skeletal meshes and uncheck static meshes. Let's clear our search filter and let's scroll down, and we have a few skeletal meshes that we're going to use as a reference for human character. So select one of the few available skeletal meshes here. I'm going to select Iron Guard Male A. Just hover over right next to the box, left click and drag right into the world. Let's go into orthographic viewport, left click to select our skeletal mesh and position it right on the ground plane. Let's go back to perspective And now we can get a better reference of how large this cube and this ground plane is just from having this character reference within the world. So you can insert as many of these as you want, and they greatly help you to keep your entire level to correct proportion and scale as you construct your environment. Before we continue, let's go ahead and save our map. But before we do that, I want to show you that autosave is enabled by default inside UDK. If you look here on the bottom of the screen, on the bottom right, you will see that autosaving is enabled. This means that once you save your map, every 5, 10, 15 or 30 minutes, depending on the setting that you chose, this map will be saved for you automatically. You can disable this by unchecking this box, or you can keep it enabled. I personally like to keep it disabled because I like to manually save my work, but if you want and you like this option, go ahead and keep it on. There are a couple of other options you want to take a look at. Go to View, change autosave options, and under package types to autosave, you can choose to save maps or content packages, and you can choose the interval of how often you want to autosave. So I'm gonna head and disable this. And now let's go to File, Save As, and inside our UDK folder, UDK version, UDK game, we want to go inside Content and inside Maps. And here is where we want to save our map. So I'm going to name this Getting Started Tutorial. Now let's click Save. So if we navigate to our C drive, UDK folder, and then UDK version, UDK game, Content, and Maps. Here's our map file. The extension of this map file is .udk, and another important extension that you'll come across is .upk, which is a package file. So if I navigate outside this folder, inside Content, inside UQ3, Environments, you will see the extension of all of these files is .upk. This is a package file that contains a specific set of textures, materials, and models that you can use inside UDK. So if you notice ASC_floor.upk, if we jump over to UDK, go to Content Browser, and under Packages, we type in floor, we have our ASC_floor. Let's left click to select it, bring back object type to all, and inside this package, we have our materials, a couple of static meshes, and textures. So our .upk is a package file that contains assets to be used inside UDK, and a .udk file is the actual map file that you see here. This next step is very important, grid snaps. When you construct your environment, you want to stay on the grid. So all of your brushes and all of your static meshes should snap to the grid lines and align to the grid. So if we go into orthographic viewport, you can see that each grid line and this object are perfectly aligned. So when you position your objects and you duplicate them, it's a lot easier to construct and put something together when all these objects snap together. If you look down here on the bottom, currently the grid is set to 16 units. We can use the drop down menu to increase or decrease the grid size, but it's better to use the shortcut key, which are the bracket keys. The left bracket key will decrease the grid and the right bracket key will increase the grid. And this check mark will enable or disable snap into the grid. For majority of the time, you want to make sure that you are snapping to the grid and that you are using grid spacing that allows you to work freely and stay on the grid. If you lower the grid too much and then you move some of the objects and then you bump the grid back up, you will notice that the object is off the grid now. So it's important that you work at anywhere between 8 and 32 grid size when you duplicate your static meshes or your BSP brushes, and only lower your grid all the way down to 4 or 2 or maybe 1 when you're doing detail work. It is also very important to know the height of the character inside Unreal. If we use the middle mouse button, hold down and drag, this will give you a ruler that you can measure distance inside UDK. The character height in UDK is 96 units tall, so this gives you a good point of reference of working with the grid and creating objects. Any environment you create needs a player start. Right click anywhere within your level, add actor, and add player start. Let's move it to make sure that it's on the ground plane. Next, we can playtest this map from the editor by right-clicking anywhere within the level and choosing play from here. The only problem is we don't have any lights. So let's go ahead and insert a test light. Right-click somewhere on the ground plane, add actor, and you want to choose add light point. This is a good testing light for this level. There are other lighting actors that you can use, such as a dominant directional light, which acts like a sunlight. But for right now, to test this map out, we just need a light. So I'm going to bring this up, and we need to increase the brightness and increase the radius of this light. So by double clicking on any actor in UDK, you'll bring up its properties. So double clicking on the light, we need to increase the radius, and let's increase the brightness. We can also change the color, but we're going to leave this at default. And now to see the effect of the light, we need to build our lights. But instead of building just the lights, I'm going to build all, which will build all the paths, all the geometry, and all of the lighting. Currently, our lights simulates what it will look like inside the level, but it's not final baked-in lighting. To see the most accurate result, you need to build lighting or build all. So let's go ahead and build all to see what it really looks like. And then we can jump inside the editor and test it out. We're going to ignore all of these errors. Let's hit close. And now it gives us a better baked-in representation of what the lighting will look like in our map. Let's go ahead, right-click again, and play from here. And now we can walk around our environment and look what it looks like from the point of view of the player. Let's hit escape to exit and go back to the level editor. So the three options to use to playtest inside the editor is you can right-click on the ground plane, choose play from here, just like we did right now. You can play in the viewport by using this icon or pressing Alt F8. This will spawn you from the point of view of the camera, so you need to move the camera a little bit closer. Or you can use play this level in the editor window. This will spawn you from the player start that we inserted into the map. Let's go ahead quickly and save all. The last thing I want to show you is how to get a weapon and a HUD to appear in game. If we playtest from here, you may have noticed that we don't get a weapon or a HUD. To make that available, let's go to View, World Properties, scroll down until you get to Game Type. Default game type, we want to change this from None to UT Deathmatch, UT Team Game, or Vehicle Capture the Flag. Let's go ahead and set it to UT Deathmatch. And for game type, for Pi, which stands for Play Inside Editor, we want to change this to the same thing, UT Deathmatch. Now let's go ahead and close. And we get our HUD and the weapon. What we just covered should be enough to get you started, so you can begin to explore further into learning UDK. And make sure that you pick up your free copy of the Essential Guide to Getting Started with UDK.